Hey, knock one more. Can we go thrift shopping?
What, 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 what.
Alright, Newton's first law of motion. An object at rest will stay at rest until acted upon by outside force. An object in motion will continue in motion until acted upon by an unbalanced force. Alright, to demonstrate this, we got a ball on a water bottle, and then we got a plate. Okay, the ball is at rest, okay, and then the unbalanced force is just like that. The ball goes right into the cup, and we're good.
Alright, another example of Newton's first law. An object at rest will stay in rest and thus acted upon by an outside force. You can see Evan's the force at rest, and Tanner is going to be the force the outside force. Alright, Newton's second law. Force equals mass times acceleration. We got a rubber band here, and we're going to shoot a golf ball and a wood chip. And we know the golf ball has a much higher mass than the wood chip, so it's probably going to have a slower acceleration.
And for the wood chip?
And as you see, the wood chip went almost twice as far. Newton's second law of motion is basically force equals mass times acceleration. So I have two flip-flops with exactly the same mass. If I throw them at the exact same acceleration, they will go the same distance. But if I throw them with different accelerations, they'll go different distances. So for the first one, I'll throw it with a lot of acceleration. For the second one, I'll throw it with a very low acceleration. Newton's second law is force equals mass times acceleration, and what Evan's going to do here is he's going to throw up a golf ball, and he's also going to throw up a football. And the golf ball has a much smaller mass than the football, so it's going to have a higher acceleration, but gravity is going to work exactly the same on them both. So if they are thrown with the same acceleration or with the same force, they'll hit the ground at the same time. So, golf ball first. Alright, football. Newton's third law, for every action, there's an equal or opposite reaction. So what Evan's going to do is he's going to throw a football up in the air, and when it comes down and it hits him, it's going to exert the exact same force on him.
Okay. This is really heavy, apparently.
Newton's third law, for every action there is an equal or opposite reaction. As you can see, Evan's sitting on this bench right here. He's exerting a force onto the bench. The bench is exerting the exact same force onto him. Or, if it wasn't, he would go straight to the ground.
Okay, Bray, when he pushes off on the ground for the skateboard, he pushes a force onto the ground right here. Well, the ground pushes the exact same force back on Bray, which pushes him that way, as demonstrated.
So basically, you got to push backwards